Let's take, for example, a molecule CH4. CH4 is methane. And in this case, how do we write the electronic dot structure? For methane, what we see is it is composed of 1 carbon atom and 4 hydrogen molecule. The way we write it, its electronic dot structure, is to determine the number of valence electron in the whole molecule. How many valence electrons are there for the whole molecule? We know there are 4 valence electrons for carbon, and there is only 1 valence electron on each of the carbon atom, but there are 4 hydrogen atoms in there. So you have 1 valence electron coming from each of the hydrogen atom, and there are 4 hydrogen atoms, so you have 4 times 1. So in total, there are 8 valence electron in a CH4 molecule. So how do you write the electronic dot structure for that? For writing an electronic dot structure, what you need to consider is that which out of these two is a central atom. So you need to consider a central atom in a molecule. So there are various rules to figure out the central atom. One of the rule is the atom which is present in least number, or the atom which is fewer in number in a molecule, is the central atom. So when I see methane, I see 1 carbon and 4 hydrogens. So that means carbon is the central atom. There are other scenarios where this rule is not followed. In that case, what we look into is the difference in the electronegativity. The difference in electronegativity. Now, what is electronegativity? The electronegativity is the tendency of an atom to attract the shared pair of electrons towards itself. And we are going to cover in some of other lectures what electronegativity is. So a central atom is an atom which has less electronegativity than the other atom. So in a molecule, what we have is a central atom and many terminal atoms. Many terminal atoms. So which is the central atom? The atom which is present in fewer number, and the atom which has lesser electronegativity than the other one. That means, what are the terminal atoms? The terminal atoms are the atoms which are present in more number. They are present in more number than the central atom, and the other is they are more electronegative than the central atom. So in case of a CH4, carbon is the central atom, whereas the hydrogen is the terminal atoms here. So once we have figured it out, our next step is to join all the terminal atoms with the central atoms. So that's what I'm doing here. Now what this joining, what these lines demonstrate, these lines demonstrates a bond. It's a bond. And what is a bond composed of? A bond is composed of 2 electrons. 2 electrons. So a single bond, so I'm writing here, a single bond is composed of 1 pair of electrons. It's a 1 pair. There's 2 electrons in there. So this line represents a bond, and bond is composed of 2 electrons. And these electrons here is called a bond pair. A bond pair means a pair of electron which is involved in the formation of a bond. Just here, this is a bond pair. Okay, pair of electron which is involved in the formation of bond between two hydrogen atoms. So that's the reason we can also show two hydrogen atoms joined by a single bond. It's a covalent bond in there. So once you have done that, so that means I have accounted for 1, 2, 3, 4, 5, 6, 7 and 8. I have accounted for all 8 electrons, 8 valence electron in CH4, in a CH4 molecule. So that is an electronic dot structure for CH4. I can also show this electronic dot structure in the form of electron pairs rather than the lines. How? So you can put 4 hydrogen atoms around the carbon atoms and have the electrons in between carbon and hydrogen, one bond pair. So there were 8 valence electron, and you can see here is 2, 4, 6 and 8 valence electrons. So this is a electronic dot structure for methane.